enjoyed doing that.
And you had some QST articles about it as well, right?
That is correct. Oh, yes.
Yeah. And they were recently reprinted by QST also, right?
And that's a fact.
Yeah. That's really neat. So is there any particular thing you remember, any particular open question from those experiments that is still unanswered that maybe we can answer this time?
Well, the simple answer is we never exactly figure out what it was. And we're proud of that because we wouldn't have a job otherwise.
Yes.
Well,
Sorry
one of my
about the
favorite
cycle.
sayings is the universe is full of magical things just waiting for our wits to grow sharper.
Who said that?
I'm trying to remember. I've been attributed in a number of different ways.
Okay. So Jim, where did you see these various eclipses? Where did you go?
I was not somebody who was going to every one there was, because that was a little bit out of what my boss had me doing other things. But we certainly have had opportunities to do that over time. And, you know, I hadn't even given a thought to it other than some of the earlier projects that got me involved in this at all, with respect to something that we did a very long time ago. I was still in graduate school. I was a little bit older for a graduate student than I was. And we had a very nice result by getting the university to authorize that it was okay to me to do it. And we set up, we were about to have a nice event with the sun going dark in the middle of the day. And we gathered up a short handful of other ham operators, and got a couple of locations that were about 150 miles apart, and when the climax occurred, by golly, we got radio. It became nighttime, and by gosh, you could get on 80 meters and actually talk to somebody. So it was a great deal of fun, and the thing that drew me on into this was the excitement in myself about how we can do it again, and probably a whole lot better than we did. We did this on the fly.
What would you do better?
We did it on relatively short turnaround, but that was still 2 or 3 months, get everything together. And the technologies that we were using were just regular ham stuff, except we were modulating the right stuff when we were on the air.
Well, I think Gareth is here now, and we have quite a crew. I saw Angel from Arecibo, he popped on here as well. So I think I'd like to get started because we only have about 50 minutes left now, and I have a couple of things I'd really like to do today. So what I'd like to do is this is really try to set some of the science priorities and goals for the solar eclipse QSO party. So, you know, many of us here come from the amateur radio community first and know a lot about contesting and a lot about the amateur radio operations. But one of the things we really need to do is we need to make sure that our solar eclipse QSO party also really addresses the science questions. So I'm going to do is I'm going to give a short review of what happened during the last solar eclipse QSO party and some of the questions I'm thinking about that we might be able to answer for the next solar eclipse QSO party, and be interested in hearing everyone's feedback from that. Sound good?
Mhm.
And
Sure.
also, by tomorrow, Gareth and I have to submit what we call a NASA Step 1 proposal to NASA, where we have to submit a 4,000 characters. It's about a one-page write-up about what we want to do. And that has to be approved before we're actually really allowed to apply for the grant. So I've gotten a draft of that going. I'm hoping that our discussion on the science questions here will help that out a little bit along. Gareth, does that sound good to you?
Sounds good to me.
All right. So this is a talk I put together for the Dayton Hamvention. I'm going to switch back in May. And so this is our HamSCI plans for the study of the 2023 and 2024 solar eclipse impacts on radio and the ionosphere. And so we all know that we have the ionosphere, and that during the day, you get more structure. So you can get the D, the E, and the F1 and F2 layers are there mostly during the day. And then at night, when the sun goes away, we get the ionisation stops and you get recombination, and you get more or less just the F and the E layer. So the ionosphere changes from day to night. And we also know that our radios, they can communicate, they can refract off of the ionosphere, and this is a function of two primary things. One is electron density. So if you stay on the same frequency, but you change the electron density of the ionosphere, the path changes. So less electron density means less refraction. More electron density means more refraction or more bending. And so this is an example of a ray trace model that was done during the last solar eclipse, going from Florida up to Wisconsin. Similarly, you can keep the background ionosphere the same, and you can change the frequency, and then your radio signals go to different places. So 15 megahertz frequency will refract less than a 10 megahertz frequency will for the same background ionosphere. So you can see here that the 10 megahertz signal takes 1-2 hops to get out to 1,500 kilometers, whereas the 15 megahertz signal takes just 1 hop to get to 1,500 kilometers. So we've got 2 eclipses coming up. There's going to be an annular solar eclipse on October 14th, 2023, and a total solar eclipse on April 8th, 2024. The annular one is going to go this direction. The total solar eclipse is going to go in this direction. So what's the difference between annular and total? You first need to know that the moon's shadow has 2 parts. you have the umbra, which is the innermost region of the shadow, and the sun is fully hidden, and objects is fully hidden from people who are in that shadow, in the umbra. Whereas the penumbra is this much bigger area out here, and that's the outermost region of the shadow. So there, the sun is partially hidden when the moon goes in front. During a total eclipse, the observer is located within the umbra, and during a partial eclipse, the observer is located in the penumbra. So even when you have the total solar eclipse, people who are outside of that total solar eclipse path, they'll still experience some eclipse, but it's going to just be a partial eclipse. And then the difference between a total and an annular eclipse. So the moon appears larger in the sky when it's closer to the Earth at perigee. Oh, come on. Yeah, one of my students just came in. When it's closer to the Earth at perigee, and it appears smaller when it's farther away at apogee. So when the moon is at apogee and it's farther away, that's going to it's going to look smaller, and it will not fully cover the sun. And so you're going to get a little bit of ring of sun around it. So that's what's the annular solar eclipse. When the moon is near perigee, you get the total solar eclipse because in the sky it's sized to completely cover the disk of the sun. So then you get these three conditions. So here's your total, your partial, and your annular. And so because the solar radiation is blocked from the atmosphere during the eclipse, we can expect the ionosphere to respond similarly to day and night. But there are differences. So for instance, an eclipse is shorter than the nighttime period. Eclipses are much more localized. They travel at supersonic speeds, and they travel in directions that are different from the westward motion of the dusk and dawn terminators. And so aside from the dusk, dawn, and the seasons, there are very few cases where we know a priori how much solar energy will be input into the sun in the upper atmosphere. Solar flares, geomagnetic storms, and other events are random, and we can't predict them. But we can calculate eclipses with great accuracy ahead of time, and so this can be considered a controlled ionospheric experiment. And so here's a path, and you're welcome to come up here so you can see what's going on. And so here is a movie of the October 14th eclipse, and this is actually what the shadow looks like at 300 kilometers altitude around the F region of the ionosphere. So you can see it's starting in the northwest of the United States and going to the southeast. And then and then the next movie, this is the total eclipse that's happening in 2024. And that's starting from the southwest and going to the northeast. So in 2017, this is a review of what happened in 2017 for the solar eclipse QSO party. It went from the northwest to the southeast, and it took about 4 hours for the total traverse here. And so we asked these research questions. We asked, can we use HF ham radio communications to observe eclipse effects on the ionosphere? And can we use data model comparisons to better understand the ham radio data and constrain or calibrate the model? And so we had our solar eclipse QSO party. We ran it for 8 hours. So this gave a few hours before partial eclipse started and a few hours after partial eclipse ended. And we made it contest-like. We gave 2 points for CW or digital, 1 point for phone, and we had multipliers where you had to multiply by the score by the number of grid squares. We said the exchange would be your RST, and we asked for people to use a quote-unquote real RST instead of just 5 nines. And we gave a 6-character grid square. And one of the reasons we gave extra points to both CW or digital was because we really wanted the automatic data collection from Reverse Speaking Network, PSK Reporter, and WhisperNet. And then we also had participant submitted logs. And so we received over 570 logs and had almost 30,000 QSOs in those logs. And we had very good coverage in all of that. And then from the automated networks, RBN, WhisperNet, and PSK reporter, we had a total of over 2.5 million observations for that time period. So this is what the RBN looked like for the entire 8-hour period of the SEQP. So little black dots are the CW transmitters, ham radio stations. The blue are the RBN receivers. And then the colored dots, those are the midpoints between a little black dot and a blue star every time a transmission was heard by the blue receiver. And it's color coded by obscuration, total maximum obscuration during the eclipse. So for the data analysis, I ended up only looking at the data points that were at an obscuration point of 90% obscuration or greater. So I threw everything, the rest of the data out. And this is an example of the observations from 14 megahertz. So I aligned all the data up so that right here at the middle, this is where there's maximum eclipse. The white dashed line is the amount of eclipse. So there's no eclipse when it's up highest. It's maximum eclipse when it's down lowest. And then this is a two-dimensional histogram of distance between transmitter and receiver as a function of time relative to the eclipse. So an hour and a half before the eclipse, there was lots of communications on 14 megahertz between 1,000 and 2,000 kilometers. Starting about an hour before the eclipse, we started to see the band shut down. And then after the eclipse ended, we started to see a recovery, and you got almost, fairly good recovery starting about an hour afterward. And then I think you went into dusk over here. So there's a little bit of an asymmetry there. That's pretty much what the band was doing. So we did that same analysis for 4 different bands: 14 megahertz, 7 megahertz, 3.5 megahertz, and 1.8 megahertz. And so you can see they all behaved a little bit differently. So the 14 megahertz band shut down as the ionosphere diminished. The 7 megahertz band went long. So your communications went from about 500 kilometer range out to about 1,000 kilometer range and then back. So the reduced refraction let the 7 megahertz signals go out farther, but didn't escape into space. The 3.5 and the 1.8 megahertz bands, they we believe that there was less absorption there, so those bands opened up. We were able to do a simulation of this. So Joe Huba at the Naval Research Laboratory, he provided us with a prediction of what the ionosphere would look like using his first principles SAMI 3 ionospheric model. And we were able to run that same ray tracing. You can see the non-eclipsed version on top versus the eclipsed version on the bottom. And this is again between AA2MF in Florida, received by Whiskey Echo 9 Victor in Wisconsin.
Daniel, what frequency was that?
This is 14.03 megahertz.
Oh, I see it. Sorry.
No problem. I'll run it again. So we used a very, very simple method of saying whether a communication was established or not. I simply had the computer say, is there one of these white rays? Can it find a white ray that will hit this particular location in Wisconsin? And if so, color it red and mark down that a communication would have been successful. So there's all sorts of ways to improve on that modeling, but we did get fairly good results. I created a grid over the entire United States of theoretical transmitters, and I kept the receivers located at the same blue stars. And then we ran that ray tracing code for every possible connection between a black dot on here and a blue star. for all 4 of those frequencies for every 3 minutes throughout the period of the solar eclipse QSO party. And then once again, I threw out everything that, all of the midpoints that were at obscuration less than 90%. And then we plotted it the same way that we plotted the original observations. And so here you can see that the model matches fairly well with the observations up on top. There are certainly some differences. The observations are more spread in range, much more spread than the model is. There's a more gradual recovery at the end in real life than there is in the model. But there's still some sort of asymmetry where the model does not recover as fast as the band shuts down over here. We also found that we actually had to separate out the simulations between the E region refraction and F layer refraction. So here are all of the observations from all 4 bands on the left-hand side. Here is the model run on the right-hand side for all successful communications. You can see here that there's really not quite perfect agreement. In fact, the agreements may be okay on 14 megahertz, but the agreement's rather bad on 7, 3.5, and 1.8 megahertz. But what I found is if I said, okay, I'm only going to look at the model for refractions less than 125 kilometers altitude, so the E region, I find that that matches up very well with 14 megahertz and everything else disagrees. So that tells me that the 14 megahertz communications probably was refracting off of the E region, not the F region during the SEQP. If I look at only F region refractions in the model, which is for altitudes greater than 125 kilometers altitude, we then see that 14 megahertz does not agree, but 7 and 3.5 agree quite nicely. 1.8 megahertz doesn't agree, but I think that's because the model actually didn't have enough ionization in it. So in conclusion, we generate over 2.5 million link soundings, and the eclipse effects were observed, plus or minus 3 hours from eclipse maximum on 1.8 megahertz, plus or minus 45 minutes on 3.5 and 7 megahertz, and plus or minus an hour from eclipse maximum on 14 megahertz. So the ray tracing suggests that the 14 megahertz were refracted at altitudes of less than 125 kilometers. This means that it was E layer. The model will actually also give us the takeoff angles. So the mean takeoff angle for the model here was less than 10 degrees. So all of the 14 megahertz communications were very low angle communications. So this suggests that the higher frequency of 14 megahertz suggested that the D layer absorption was not a problem, even at these low elevation angles. The low angle rays could be refracted by the E layer because of the secant law, but the higher elevation angles, they penetrated both the E and F layers and they escaped out into space. If we look at the lower bands and we compare it with the ray trace, we found that it agreed best with the refractions at greater than 125 kilometers altitude, which means F layer refraction. So here, the elevation angle of these rays was greater than 60 degrees. So this suggests that the low angle rays were likely absorbed by the D region and not observed, but the higher elevation angles penetrated the E region, but they could not be refracted by the F layer. But they could be, so they penetrated the E layer, but they could be refracted by the F layer. So that brings us to where we are today, which is we want to run the solar eclipse QSO party again for 2023 and 2024. And in a few minutes, I'll ask you, what would you change? Would you keep the same? It gave you the dates. Interestingly enough, the annular eclipse is going to be on a Saturday, which is probably good for ham radio operations. The total eclipse is going to be on a Monday, which is less good, but it'll still work out. And these are some of the science questions that I've come up with already. Can the annular eclipse be observed in HF communications? How large is the disturbance? How long before and after maximum eclipse are eclipse effects observed? Is an onset recovery asymmetry observed? Will the results again suggest E layer propagation for 14 megahertz and F layer for 1.8 to 7 megahertz? And maybe not, since we're going into solar cycle 25 and we can expect the background ionosphere to maybe be a bit more robust than it was back in 2017. How similar are the eclipse effects from dawn and dusk? How well does the model prediction of the bottom side HF structure and dynamics match with actual observations? And can we use HF communications to inform us about the large scale bottom side structure of the eclipse? So those are all questions that I put down. So with that, I'll open the floor to comments.
Nathaniel N0AX.
Yes, Ward.
Okay, just an administrative note here. These are starting to get within about a year out or more,
Yes.
but not too much more. It's
Right.
really important to get people thinking about this now, even if we don't have the details, especially the software authors that deal with logging programs, the contest calendar guys, all that stuff. So I think it's really, really important to announce that there will be a solar eclipse QSO party on these dates.
Yes.
And say the details of the contacts are still to be determined, but they aren't likely to be wildly different than the solar eclipse for 2017. But it's important to get this on everybody's calendar and get them thinking about it, and then paying attention so that when we do come up with the rules, everybody is already made a hole in their schedule and they're looking for it.
That's absolutely correct. So Gary AFAA, who's usually very reliable and shows up to almost all of our GRAPE meetings, for some reason he's not here today, but he specifically volunteered to be the amateur radio coordinator of these contests. So that would be something I can send Gary an email and CC you on it, and that should fall under Gary's job of getting that communication out.
Okay.
Would it be helpful to have a article published based on the slides you just went through, Nathaniel, to kind of get people interested and thinking more about it?
Absolutely. Ward, do you have any comments on that?
QST will not run anything beyond an announcement. They're interested in what happened, but they're not so much interested in a promotional article, although there are other things going on with HamSCI, as you and I have discussed. They might include the QSO party in that kind of an article, but they're not going to run a prep article on it. National Contest Journal might run an article in it on the air, and is not really your target publication. And QEX might be interested in some of the scientific or measurement articles. I think you'd be far better off to focus on social media and electronic media in general, which doesn't have a space limitation, and the lead time is much lower.
Hey, Ward.
Yeah.
CQ might have something too. They might be a little bit open to that. I'm not sure if they have quite the audience of QST, but that might be another platform. National Contest Journal, kind of a narrow audience, but they might be open. They might really be open to something like that. I think that would be a good place to look at it.
Well, the thing is that all ARL members get all 4 of those publications. So you really get one big magazine every month, and NCJ is just the sports pages. Is the way it is. And so if there's going to be a competitive event, they might cover it from that angle. Whereas how to participate might be, I don't know, maybe we could get something like that on the air. But
I
we
wonder
have
if
a
we-
very long lead time. So if we're gonna have this article, the time to start talking about it with Becky Schoenfeld is right now.
I wonder if we could get more scientific pre article done in something like QEX rather than QST itself.
Yeah, I think QEX, talk to Kai Siwiak, KE4PT. ask-
Why would QST be so against running a pre-article?
Because first of all, their editorial schedule is probably already determined out into next year. They're very focused on how to and explanatory articles. They're not really, this is my understanding from talking to Becky about stuff. They're not really interested in these general purpose type of, gee, isn't this great type of article. They're just not. So
But
maybe
this wouldn't be just a, gee, isn't this great type of article? This would be, creating a real on-the-air event with a very specified purpose. That's a very different.
I agree, but I think you'd be far better off to use social media, let QST announce it, let the ARL run some promotional items in their ARL news and things like that. But QST is more of a reporting. They would be interested in a reporting article, I think, more than a prep article.
You've also got.
QST was
Podcast.
kind enough to run small features for the Eclipse festivals in the I forget what it's called at the end. It's not like Shouts and Murmurs, but it's sort of their equivalent of that. And they were willing to run those when I sent them about 3 months out. So I would say ask Becky if it would be possible to do like a half a page kind of thing.
Sure. Yeah. And their
Should
contest
I send Becky? I can send Becky an email and ask her myself what she would be willing to do.
Yeah.
Why don't I do that?
You've also got the podcasts that are on too, the Eclectic podcast and other avenues as well that there's a lot of ham radio of outlets and different social media like you were talking about that has an audience.
Mm-hmm.
And you've got the WB7, I don't remember what it is, Ward, but he's got his contest page and other things. And there's a lot of different.
I think the podcasts are probably a good way to go. And one of the things that's nice about that is there's a lot of different ham radio podcasts and YouTube channels, and there's a bunch of us on this call. So it's an opportunity for almost everyone on this call to, if they want to get on a podcast, they can get interviewed and talk about this.
I think it's important to announce it now so that everybody gets on their calendar. And when we get some specifics, then go on the podcast. Because if you can't answer the questions about, well, what bands is it going to be on? How do I make a contact? How is it going to be scored? Where's the data going to go? All these, you're immediately going to have 5 or 6 popular questions. We need to have answers to those questions if we're going to be interviewed. Otherwise, it's just too soft.
Yeah.
In my opinion.
I think
okay.
I think my enthusiasm got a little bit ahead of my thinking about that, Ward. And we might even want to have some standard things out of the group so that the questions have at least some consistent, or answers have at least some consistency as well.
Yeah, I agree. So I'm going to move it back to the science for a minute, because while I agree with Ward that we have to get this announcement out as soon as possible, I also have a 10 a.m. deadline to submit a step 1 proposal to NASA tomorrow that's going to have the science questions in it. So those are also very pressing. So I still have the science questions on the screen here.
Nathaniel, I have one thing, wondering if we can, my interest would be adding some timing information. I presume we'd be doing Doppler shifts and such on various things. But
Yeah,
I don't know.
we
if
already
yeah.
have in hand, we've already been awarded an NSF grant to do the grape observations and Doppler that way.
Right. But I'm thinking in terms of ham operation, if there's anything we could do like coherent CW or something like that. But maybe
Yeah.
that's a little too complicated to talk about here.
It may not be. So one of the things we did in the last SEQP is we did have like different categories and as people came up with different things they wanted to do, it's like get involved. I created these multiple different blocks. So people who just wanted to do solar eclipse QSO party, they could do that. People who wanted to do HF frequency measurements, I set up a separate page for that. People wanted to do HF wideband recording, I did that. So, you know, if you wanted to have a specific program for the what do you call it, for the timing community, we can
Right.
certainly set up a page for that. And we can also possibly, you know, figure out how to include that participation in the SEQP.
Right.
Nathaniel, Gwyn Griffiths here, G3ZIL. Along these lines, one of the technologies available now that wasn't in 2017 is the embedded feature within FST4W to measure spectral spreads. It's not terribly well known, but it's actually quite an interesting measurement that a lot of people could get involved in.
All right, so embedded feature in FST4W.
Yep.
I did not know about that.
Okay.
Another aspect I wanted to mention is with an annular, that's an annular at the surface. It is more total up at the ionosphere, which might be an interesting thing to try to measure.
David, that's a good comment. I was surprised. Sorry, this is Gareth, KD2SAK. The difference between in terms of, I don't want to say influence, but EUV flux, I guess, on the ionosphere between a annular and a total, apparently it's not a huge amount. Like, it's not a significant amount in terms of production and loss. Chemistry. I was told by a colleague, Sebastian Marak, who mentioned this in a talk. So so when they say, you know, studying the effects of the eclipse, if you're studying like an annular and a total, you could probably get away with studying some of the same effects with both, because the difference in terms of how the flux changes is not a huge amount between the two.
So difference in EUV flux between annular and total eclipse at ionospheric heights is minimal.
Yeah, it's not like, you know, 50% or 30%. It's apparently it's quite small. I always had the impression that, you know, they would be completely different, but apparently I'm wrong about that.
Might be to get some information on David's idea, and I think it's a good one. Those eclipses, the path of totality is just about going to bowl right over the Austin ionosonde. And that's straight up sounding. You might be able to see some effects in the ionosonde data. The path of totality is going to go right over the top of it. Of course, it did the same thing with Boulder and I guess Alpine.
Right. Yeah,
Idaho
absolutely.
National Lab for
ionospheres will-
2017.
Yeah, that one.
The ionosones will definitely have effects. Let me read to you what I've written. So I started writing this afternoon. This is my draft for the step 1 proposal, and it's still a draft, but that's okay. 2 solar eclipses will traverse the continental United States CONUS over the course of the next 2 years. An annular solar eclipse on October 14th, 2023, and a total solar eclipse on April 8th, 2024. During a solar eclipse, light from the sun is temporarily blocked by the passage of the moon. In addition to a tremendous visual display, this temporary cessation of the insolation causes both a reduction in photoionization and a cooling of the atmosphere, leading to dramatic changes in ionospheric electron densities and dynamics. These changes in the ionosphere impact several important technologies on Earth, including satellite navigation, e.g. GPS, and terrestrial medium and high frequency communications. Furthermore, solar eclipses serve as controlled atmospheric experiments in which the major inputs are known a priori, a rare occurrence in the field of atmospheric physics. The 2024 eclipse will be the last solar eclipse to traverse the CONUS until 2044. This project will study the atmospheric response to the 2023 and 2024 eclipses through a series of large-scale citizen science experiments known as Solar Eclipse QSO parties, SEQPs. The data for these experiments will be generated by amateur radio operators communicating with each other over and around the eclipse paths using, again, medium and high frequency MF and HF signals that are refracted back to Earth by the ionosphere and hence sensitive to eclipse-induced atmospheric changes. The 2023 and 2024 SEQPs will build on the success of the SEQP held during the 21 August 2017 Great American Eclipse, which generated over 2.5 million radio contacts over the 8-hour period around the eclipse. The 2017 SEQP showed evidence of ionospheric electron density reduction that caused 14 megahertz band degradation and 1.83 and 7 megahertz band enhancement because of the eclipse. These observations were successfully modeled by ray tracing through an eclipse version of the first principles physics-based SAMI-3 model ionosphere. This allowed the amateur radio observations to be linked to physical parameters and provides a route towards model validation and data assimilation. While the 2017 SEQP was successful, is a single event that opened the door to new research questions. The 2023 and 2024 eclipses have different paths and types than the 2017 eclipse, and therefore will give new insights to the atmospheric response to the eclipse. Specifically, the following questions will be addressed. And then I have the same questions I listed before on the PowerPoint slide. And that's as far as I got. So then other people were suggesting.
Can I interject here a moment, Nathaniel? Nick Hallpatch, B7 Delta X-ray Romeo.
Yeah, hey, Nick.
Yeah, it seems that what you're driving at is something to do specifically with the solar eclipse QSO party.
Right.
That you have, and this is what you're trying to write up right now.
Yes.
Okay, that's because there's all these other potential observations that could occur to do with the solar eclipse, the HamSCI is interested in, but
yes.
That's not what you're trying to prepare right now. You're just trying to prepare this for the solar eclipse QSO party.
That's correct.
Okay, is that means that some of us are probably going to stand back and just say, okay, go ahead. Again, looking at the your scientific suggestions and say, okay, does that seem reasonable? Given your experience and so forth, and as far as from my limited understanding, yes, they do seem reasonable. I don't see anything that specifically needs to be changed or added to, but others who have taken part in what you did in 2017 would
right.
have something more to say about it. Okay.
Thank you. Yeah, so that's right. There are definitely other things that can be observed in this, but we're specifically working on the solar eclipse QSO party right now. Gareth, do you have any comments on the science questions?
Can you put those back up again?
Did they go away?
There they are. No, I got it. The only thing I'm going to say is that number one has already been established.
Mm-hmm. The annular eclipse?
Oh, okay. Yeah. But if I'm really picky, I want to say how large is the disturbance is too general, too vague.
I
A
feel like it
statement.
is a little too vague. I feel like that would need to be specified a little bit more.
Yeah,
I feel like
go
I
ahead.
feel like I should, you know, I can't have too many science questions or too many research questions, or they say you have just too many of them. So you have to. I think trying to narrow this down to a smaller set is good. And I think even possibly from doing the decadal survey papers, there seemed to be quite an interest in this operations to research loop. So there may be some ways, some questions that are more specific to actual propagation and modeling propagation that we may be able to legitimately put in here as well.
V7DXR again. One thing, that may not be immediately obvious unless somebody's really familiar with the solar eclipses is the path for the annular eclipse is remarkably similar to the one in 2017. So I don't know if that has any bearing on, sort of, well, we should take advantage of this because it's pretty close, in terms of our original data. And the locations of our original data gatherers, will be fairly similar to what the annular eclipse, the path, and so forth is quite similar. It's again, I can't say from the point of view of the science how important that is.
Nathaniel, I didn't see whether you're specifying modes or anything.
I haven't at this point. Hold on. It helps us see the difference between the annular and I don't know that it's super important to specify unless there's a special feature like Gwyn pointed out how FST4W measures spectral spread, which is new. The reason I'm not sure that it's that important for today is because the bar I have to pass for tomorrow is relatively easy. I just have to write a 4,000 character thing that they will basically say, okay, we think this is feasible, and we'll invite you to submit something that's more detailed. And I think in that more detailed proposal, and when we write the SEQP rules, then we would really specify the modes.
That makes sense.
I don't even know what FST4W is. I gotta Google that.
I did that. That's another Joe Taylor in Princeton software program. I've got to download it and see what it does.
Gareth, did you have comments on these, Gareth?
No, those all look good to me. Just have down to perhaps 3.
Yeah, so if out of these, which ones are your favorite? I kind of like the onset recovery asymmetry.
Yeah, that's a good one.
I feel like this one, we might be able to.
I think 8 is a good one. 7 is a good one too.
7 and 8 could almost be combined.
Yeah.
Because they're both looking at bottom side structure.
Yeah, 8 is a specification of the.
I also, for the purposes of this proposal, I almost don't want to play up the annular eclipse too much, because the proposal call actually only says to study the 2024 eclipse. but I feel like the 2023 annular eclipse is just a really good opportunity along the way, to, you know, to have another operating event to kind of keep, you know, keep interest going. And I think I don't see a reason not to do the 2023 eclipse.
You could call it a dress rehearsal.
Yeah,
Yeah.
I mean that was something I was thinking of too. Like, yeah, it's practice. It's it can act as kind of control data. It's similar to the 2017 path. I think, you know, I think there's some interesting science in its own right. I think it'd be wrong to just ignore it.
Yeah, I think you should approach it from the standpoint of developing a certain expertise within the amateur community in performing these large-scale propagation experiments, and developing expertise in the research community as to how to collect the data and manage these events, so that the partnership develops this ability to go out and observe these events. And we can apply this. Right now we're doing a series of eclipses, but we can apply this to all kinds of interesting things that are known in advance. And you could even have the flash mob kind of thing where you say, hey, something is happening or is about to happen, and we need everybody to fire up their solar eclipse event in their logging software and do one. But at any rate, I'm getting ahead of myself here. The idea would be to approach it, the annular eclipse, as another opportunity to develop this expertise within the HamSCI community.
But I like the, also just the long-term, capability, of being able to observe something, some sort of ionospheric, geomagnetic event, that happens, spontaneously, and to be able to sort of call up, sort of a group of observers right away using techniques that have been developed before.
Yeah, and this is Gareth again. I almost wonder the reason why they left NASA, that is the 2023 annular, out of it, is perhaps I almost suspect they don't expect people to be able to, organize themselves and deploy, say another proposal, an instrument quick enough to do that. But I think, with the ham community, we can do that, right?
Yeah.
So I think, to me, I think I think it's okay to mention 23 and 24 eclipses, because it's like, why wouldn't we? We have the ability to do it.
Right.
We have 2 eclipses, 1 annular, 1 total. Like, let's go for it.
Yeah.
Yeah.
I thought some of the reason might be limited funding, because they only put out 1.5 years for this proposal. So they're kind of de-scoping it a little bit. But
it's not going to cost them any extra from us.
No. And I think it's something we'd enjoy doing too. And I think it'd be a really good, data set to have.
Well, and the only difference would be that was the first question. Can we see it with an annular eclipse?
Yeah.
Right? That's all. The other science questions would be the same for both eclipses.
Right.
The one thing that may be really interesting too is thinking back to the 2017 eclipse and the QSO parties. If you look at that distribution of hams, right? It's heavily, if I recall, it's heavily distributed, like the population is, to the east.
Yeah.
And the annulars on the west. And I wonder if that will have how much that would affect the experiment, or the ray tracing simulations and so on and so forth. So
yeah,
I think there'd be a lot of advantages to studying both and getting same amount of science, or a lot of more science out of it, than just simply ignoring the 23.
I agree.
But I guess seeing that they're, specifying the 2024, maybe emphasizing that, we're working on the 2023 annular eclipse anyway, that's going to happen, whether they come through with extra money or not, isn't it?
Yeah.
And sort of a way of, this is not so much a science requirement, just simply sort of an expression of good faith. We're going to be doing this anyway, and that's even more reason to take it seriously.
Yeah. Well, we're at 5 o'clock Eastern now, and so I don't want to hold people longer than we said. So I'm going to close out the formal part of the telecon now. And I'm going to make an announcement. Next week, there will be no telecon. And that is because next week is the Tapper Digital Communications Conference in Charlotte, North Carolina. And a number of us will be sitting on airplanes during this time. And so it's going to be very hard for us to be on a telecon having this. So I'm actually going to be giving a presentation at the Tapper DCC about some of what we're planning for the upcoming eclipses. In addition to some other updates from HamSCI, there's a lot of HamSCI presentations at the DCC this year. So if you're not going in person, you can watch us on YouTube on Friday and Saturday. But otherwise, we will be, we'll reconvene 2 weeks from today. And I think, Ward, your point is really good about getting the word out right away. So I'll send Gary an email to try and loop him in, and then maybe I can have loop you in as well, and we'll have Gary be in charge of getting that word out. But maybe he can reach out to both you and me for like contacts or suggestions on who he should talk to.
I know all kinds of people, so I'll keep him.
I know you do. And Gary's also deputized to find other people to help him. So if people, one of the things I'm trying to figure out with running this whole HamSCI thing is how to, lots of people want to help. Sometimes it's hard to figure out what people's talents are, what the best way to have them help is. So if you have a particular thing you think you're good at, and feel free to volunteer or make suggestions, and that's been very helpful so far. So all right, I will leave the telecon on for now. So I'll turn off the recording, but if anyone wants to stick around and chat, I'll be happy to hand over the hosting to anyone who wants that. And if not, feel free to sign off, and we'll see you in 2 weeks or in Charlotte.
Hey, Nathaniel.
Yes, Steve.
I like all the standard ham radio crowd measurements, but we've got enough time to set up maybe a little more